Hello everyone, welcome back. This is Chandan and you're watching the learning field. And in this lecture, we are going to solve the question of CSIR net December 2025, the Markov chain, questions of Markov chain. So in this paper, actually two questions comes in the paper. One is of 3 marks and one is of 4.75 marks. So total 7.75 marks comes in this paper of December 2025 CSIR net. So before starting, I'll request you all those who are new in my channel, please give a like to this video, share with your friends, and subscribe the channel. And one more thing is that those who are new in my channel, I am just going to share is that uh, already I make a playlist on Markov chain. Okay, so there is a complete playlist of Markov chain. I think there are 8 videos or 8 lecture of Markov chain and the complete lecture. Not only a single thing, that is complete lecture series of Markov chain is available in my channel. You can just go to my channel and playlist section and you can definitely find the playlist for Markov chain. Fine. And it is very interesting to me and I am very happy to share that the videos are like highest one videos got I think 22K plus views. So that you can see that this is a very good impact on YouTube for Markov chain playlist for me also and for you also. So 22K plus peoples or learners are watched have watched that videos. That means they are definitely some good content in that playlist. Okay, so you can obviously definitely check the Markov chain playlist if you want to prepare for CSR net Markov chain. And I can guarantee that after watching my playlist, you can solve all the questions of Markov chain that comes in CSR net exam. Fine. So for this lecture, I will refer my playlist. I lecture series. I think lecture 6 and lecture 7. That two are, I think, based on stationary distribution because the question that have asked in the CSR net paper, two questions are based on both the two questions are based on stationary distribution. Sorry, I think one question is this one, yeah, stationary distribution. Okay, so you can definitely consider the sixth and seventh lecture of my lecture series that dedicated on the stationary distribution. Though the first question is here, let Xn be any homogeneous Markov chain on the state space S having transition probability matrix this equal to given which of the following statements about stationary distribution of any such Markov chain is true. Fine. So, uh, I'll just remember or reminder you that what are the theory behind this to solve the question. Fine. So first we draw the directed graph, and I already shared all of my Markov chain playlist that 90% of the Markov chain questions can be solved only by drawing the directed graph. So if I draw the directive graph first here, 1, 2, 3, and 4. These are the 4 state of the Markov chains. Now, if we draw, so 1 to 1 probability, yes, there are 1 to 1, 1 to 2, not 0, 1 to 3, with probability 1 by 4, with probability 2 by 3, and 1 to 4, with probability 1 by 12. Then 2 to only possibility, this is, and then 3 to 1 possible, yes, 3 to 1 with probability 1 by 12, 3 to 3 possible, 1 by 4 probability, and 3 to 4 with probability 2 by 3. Then 4 to 1 possible, yes, 4 to 1 with probability 2 by 3, 4 to 3 with probability 1 by 12, and 4 to 4 with probability 1 by 4. See, this is the one and all the elements of the row and column, corresponding row and column are 0. That means, and 2 is and different state, that is there is no connection between 2 and in these 3 state. That means what this 2 is, and uh, that means there are two actually closed space, that is 1 3 and 4, this is 1, and only 2 is 1. That means this 2 is absorbing state. We can say this is absorbing state. 2 is absorbing state. Now, 2 is observing. And these three makes a closed communicating class. This 1, 3, state 1, 3, and 4 are build a stationary, closed communicating class. Now, if 2 is an absorbing state, then definitely if pi is the stationary distribution, which is equal to pi 1, pi 2, pi 3, pi 4, then definitely this pi 2 is equal to 0. Fine. This pi 3 equal to 0. And also it is noted that the Markov chain is a reducible chain. Okay, because this 2, there is no connection from 2 to any other state. That means 2 is completely different. Okay, so this chain, the total chain is completely reducible chain. Now I want to share one just theory like things that is important for it, this question. So that says that for a Markov chain, for any Markov chain, fine, there are, what are the possibilities of stationary distribution that you want to know, need to know here, which is for any Markov chain, either unique or no or infinite stationary distribution. You can see my videos of lecture series. I already discussed that. So unique or no stationary distribution, these two things comes for irreducible plus aperiodic chain. PERIO, aperiodic chain. And this infinite stationary distributions only comes from for reducible chain. Fine. And here you can see that this chain is a reducible chain. There are classifications also in which case unique stationary distribution or no stationary distribution. Fine. So that can you also can see my playlist. You can, I am already discuss these things very nicely on that playlist. I think sixth or seventh lecture. That means if this chain is a reducible chain, then definitely the stationary distribution, number of stationary distribution is infinite. These three options are incorrect. Fine. There are three cases में possible: unique, no, or infinite. ये option 3 is never possible because this kind of option cannot happen for a Markov chain. Two stationary distribution may never happen. Okay, either no or unique or infinite. There are only three cases happen: unique or no or infinite. So for reducible chain, these two cases occur. For irreducible chain, and for reducible chain, infinite stationary distribution happen. Fine. This is the very basic thing to solve this question. You don't need to go more detail on this to solve this question. Okay. Next question. Next question is a part 3 question. So it says that suppose the transition probability matrix of a homogeneous Markov chain state space this one, which of the following statements are true here? Fine. Uh, so it says that state 2. So first we draw the directed graph. Fine. So 1, 2, 3, and 4. With the probabilities, if we draw, then 1 to 1 possible, 1 to 2 possible, and if we see that this is a 0, therefore these two makes a closed class. So 1, 2, then 2 to 1 possible, yes. Then what? 3 to 1 possible, yes. 3 to 2 not possible, 3 to 3 possible, yes. 3 to 4 not possible, 4 to 1, 4 to 2, 4 to 3 possible, yes, and 4 to 4 possible. See, if you can go outside from the state 4, then you cannot revert back to state 4. That means 4 is transient state. Fine. Similarly, if you go back from state 3 to 1, then you can never back to 4. That means 3 is also transient state. And also, you can see that uh, if P3 and 4 are transient state, that means if pi is the stationary distribution, pi 1, pi 2, pi 3, pi 4, fine, then since they two are transient state, therefore pi 3 equal to pi 4 equal to 0. Fine, pi 3 and pi 4 are 0. Now, if we see that 1 and 2 makes a closed communicating class, fine, 1 and 2, because of, if you see that P11 plus P12 is equal to 1 and P21 plus P22 is equal to 1. That means they two makes a closed communicating class. Fine. Now, what happened is that means option 4 is transient state. Yes, this is true. State 3 is periodic and ergodic. No, because aperiodic and ergodic, state 3 is a transient state. So it is not a, I think, ergodic state. No, 3 is not a ergodic state. Fine. Because if this is ergodic, then all state should be recurrent. If 3 should be recurrent, recurrent plus irreducible plus aperiodic. If aperiodic state aperiodic, then it is ergodic. But here this recurrent condition fails. That means state 3 is never ergodic. Fine. Remember, if one state you have to show that it is ergodic, then you should check whether it is recurrent and irreducible and aperiodic. In fact, ergodic means what? Ergodic means non-null persistent. Non-null persistent or non-null recurrent or positive recurrent. The same name, positive recurrent. Right? So this is not true. Now state 2 is a positive recurrent. If we see that these 1 and 2 are, yes, they form a closed class communicating. That means 2 is obviously recurrent, 1 to both, because they form a closed communicating class. They are recurrent. And what is the periodicity of any one state? Suppose if we check the periodicity of 1, periodicity of 1 means GCD of D of 1, GCD of 1 to 1 possibility. So 1 to 1 possible in one step, possible in two step, possible in three step, and so on. So that means GCD equal to 1. That means this is aperiodic. Fine. So aperiodic condition satisfied. This satisfied. Also this is irreducible. This condition is also satisfied because 1 and 2 are close communicating class. Close communicating class already we have checked. So this is recurrent state. In fact, positive recurrent state. Yes, this option is true. The mean recurrence time for state 1. So now mean recurrence time for state 1. So how can we calculate this thing? 4 by 7. Mean recurrent times mean what? Mu jj is equal to 1 by pi j. That we have to find what? We have to find the pi j value. Pi 1. So if we see that summation pi 1, that is pi 1 plus pi 2 plus pi 3 plus pi 4 equal to 1, and pi 3 pi 4 are 0. That means pi 1 plus pi 2 equal to 0. And if we simply apply pi p equal to pi, pi p equal to pi, you can just calculate. Okay, pi p equal to pi, then uh, pi 1 by 4 plus 3 pi 2 by 4 equal to pi 1. That means 3 by 4 pi 2 equal to uh, pi 1 minus pi 1 by 4. 3 pi 1 by 4. I think this is wrong. If we simply apply pi 1 plus pi 2 plus pi 3 plus pi 4 into pi p equal to pi na, pi p, pi 1 pi 2 pi 2 pi 3 pi 4, pi p equal to pi 1 pi 2 pi 3 pi 4. If we just simply apply, then what we have get? So pi 1 into 3 by 4. So you can just calculate one thing. I just write here that pi 1 value is 4 by 7 and pi 2 value is 3 by 7. I forget that I have just calculate here. So you can check this thing, okay? 4 by 7 and 3 by 7. And what is then mu 1 1? Mu 1 1 value is 1 by pi 1. 1 by pi 1 means 7 by 4 and mu 2 2. If the question asks mean recurrence time for state 2, then it should be 7 upon 3. So mean recurrent time is 7 upon 4. This is correct. Fine for pi 1. So option 1, 2, 3 are correct option, 4 is incorrect option. So these are the two questions of CSIR net Markov chain. I think this should help for your preparation for your solving the PIQs. So if this video is helpful for you, then definitely give a like to this video, share with your friends, subscribe the channel. Okay, thank you. Bye.